So we found some areas. What have we found the area of prior to today? Found the area of a what? A triangle. What? Rectangle. There was another one that is a rectangle, but it's a square. A square. No, we haven't done the area. Have we done parallelogram?
It was like a rhombus, but it was parallelogram.
Yeah, we did. Did we do parallelogram?
Yeah.
I'm looking at today's lesson. Yeah, we must have. Yeah, what's the area of That's right. Remember talking about that. Yeah, it's the same as a rectangle. So what's the area of a parallelogram? What's the? Yeah, we say base times height. Let's use base times height in here. Okay. All right. So what are some other quadrilaterals? Well, we have a trapezoid. That's another quadrilateral. So let's do the area of a trapezoid. Remember, I asked you to start keeping a list, right, of all these areas. Do you have one special place where you're putting this? You should, okay, whether it's in your notebook or a separate sheet of paper or something. You need a spot where you're listing all these formulas. Okay, so make sure you do that. Casey? No eating in here. If you would have just opened it quietly, I probably wouldn't have even noticed, but you're making all that racket. We just had lunch. All right, here we go. Here is a. See, everybody was paying attention. So here we go. All right, this is. All right, here we go. These two lines are parallel to each other. So what is this thing right here? This is a what? A trapezoid. Now, I do have this little thing in my notes to show you how we get the area of the trapezoid, but it's very similar to the area of a triangle. How did we figure out the formula for the area of a triangle? We just took a rectangle and we did what? We split it, right? So you get two triangles. Both the triangles are exactly the same. And so the area of the triangle is the base times height, what? Divided by 2. But a trapezoid doesn't just have a base. If you think about this, you probably haven't even thought about this before, but watch. If I took this trapezoid, if I took this side of the trapezoid and I took it way up here like this, and I took this side right here and I took it way up here like this, eventually, I don't have enough room here, but eventually, what's it going to make? It's going to make a triangle, isn't it? Okay? So a trapezoid, if you think about it, is kind of like a triangle, but you just cut it, you cut the top off, right? But you cut it off so it's parallel to the base. Would you agree with that? So it's kind of like that, isn't it? If I'd extend that up here, extend it up there, it's a triangle, and then we cut it right here, right? And we got what's left over. And that's basically what a trapezoid is. So I'm just going to show you what the formula is. I'm not going to go through like how we get it. All right, I did with my honors class, but with you guys, I'm just going to show you the trapezoid. So first of all, we have to understand that we don't just have one base. We have two bases. We'll call this B1 for base 1. We'll call this B2 for base 2. Everybody see that? So do you remember what the area of a triangle is? What is it? 1/2 base times height. So the area of a trapezoid is very, very close to that. Let's put one other, tell you what, let's do some different color. Let's put another thing on here. What if I drew from this here, from the top, and then I drew it perpendicular to the bottom? What do you think that is? What do you think that purple line is to this trapezoid? That would be the height of the trapezoid. Agreed? So that would be the height. I mean, I could have drawn from anywhere on this parallel line perpendicular to the other base. That would be the height, wouldn't it? I don't have to start like right at that point right there. I could have started right there and then dropped it down to there. Couldn't I? Mm-hmm. All right. So if I said that was perpendicular and that was perpendicular, that would be the height as well. It's supposed to be an H. Doesn't really look like an H. There we go. Okay. So the height is the same all along here. So let's figure out what our formula is. It's very, very similar to the area of a triangle. So, and the way I remember it is triangle and trapezoid both start with a T. So their formulas are very, very close to each other. So it starts off with 1/2 again, but it doesn't just have one base, does it? How many bases does it have? So what do you think I'm going to do with both of those bases? I'm going to add them up to get one big old base. Okay? So it's 1/2, the base, right? It's actually two bases, but it's the base times the what? times the height. And that is your formula for the area of a trapezoid. As simple as that. And again, if you look in the book, they go through and they do this explanation. They drew a line right here. You got a couple triangles, and they show you that you can split this trapezoid into two triangles. And once you do, and you work some stuff out, it eventually comes out to this. All right, but we're not going to worry about doing that for you. If you want to watch the honors geometry class, I do that for them, and you can watch it if you like. But that's it right there. It's not that hard to remember, is it? Remember, they both start with T. So the area of a trapezoid is very, very close to the area of a triangle. What's that? Oh, you got to go? Okay. You got lacrosse? Okay. All right. So that's the area of a trapezoid. We'll put a little T right there. Okay, for trapezoid. Nico, you play lacrosse too? All right. Easy enough. You too. All right. Good luck. Who are you playing today? Is it here or there?
Here.
Okay. I would come, but I'm playing disc golf today with another Redline graduate. He was my student. He's actually a Maryland State cop now. Did you know that? Maryland State Trooper. So he's a police officer. No, there's no competition. Because he's so much better than I am. That's why there's no competition. No, he's really good. He's been playing a lot longer than I have. He's a lot younger, stronger, and everything else. But that's all right. I've learned to live with that. All right, we got another trapezoid. Looks a little different, but still a trapezoid. And they tell you it's a trapezoid, okay? They don't even put the what do you call those things? The parallel line symbols there. But we could if we wanted to. They tell you it's a trapezoid, all right? And they tell you this. They tell you this is 4.25, and it's in inches. They put the little 2 dash thing here to represent inches, and this down here is 3.25 inches. Put the little inches thing right there. They give you everything. All right? I mean, it's they make this super easy for you. It can't be really any easier. Well, the decimals make it a little bit tough, but you got a calculator. You can figure it out. All right, so this is what they give you. They give you everything. Now, if they just put this 4.25 here, does it mean the 4.25 is this little section or this little section? What does it mean? It means it's the whole thing, the whole entire, from here to here. Oops. Let's try to make that a little straighter. Right there to there. Everybody understand what that means? Those little things right there. So the 4.25 is that whole thing. What's the 3.25? It's this whole bottom base right there. Remember, trapezoid has 2 bases. And they ask you, what do you think they ask you? To find the what? Find the area of it, okay? That's what we just finished doing, and that's what they're going to ask you to do here. Find the area of this thing. So we got a formula. What I would do, every time you see a trapezoid and they ask you to find the area, I would write down the formula every single time, all right? Some people say, well, I see it in my notes. Can't I just plug it in? Yeah, you could, but the way to remember this is to write it down every single time, all right? If you write it down every single time you do one of these problems, you'll have a better chance of remembering it. So what is the formula? It's 1/2, what? The 2 bases added up, right? So base 1 plus base 2 times the what? Times the height. And now there's nothing difficult about this at all. We just plug everything in. So how do we do that? Well, we go 1/2, B1 plus B2. It doesn't matter which one is B1 or which one is B2. No, because you're just going to add them up anyway, right? So it doesn't matter which one's which. So I'm just going to go 4.25 plus 3.25 times the height. And they tell you the height, which is just 6. If you wanted, I don't know if you can do this in your head. Just put in a calculator, okay? I don't care that you do this in your head or you do it by hand. You know, what would you do first, though, in the calculator? I would do this. I would add this stuff up. So what would that be? 7.5, right? So 7.5. And then what's 1/2 of 6? It's 3. So this would be 7.5 times 3, whatever that is. It's 22.5. But you can put it in a calculator. That's perfectly fine with me. And it is area. Remember, area, it's always what? This is inches. I'll put the inches right there. It's inches what? Squared. Area is always squared. Everybody got that? Every time they ask for the area, it's going to be whatever the units are squared. Right? It was in inches, so it's inches squared. Don't square the 22.5. Somebody did that. I don't know if it was in here. Might have been the other class on the test. But I remember somebody squaring the 22.5. The 22.5 is not squared. It's just the inches that are squared. Okay? All right. I'm trying to help you out here because of other mistakes that people have made. Let's learn from their mistakes and not make the same one. So it's just 22.5 and then it's inches squared. Couldn't be easier, could it? Let's do another one and then we'll quit. So we did trapezoid. We did the area of a trapezoid. What's another area thing that we have talked about before? A quadrilateral. What's another quadrilateral? We did parallelogram. We did rectangle. Well, triangle's not a parallelogram. Yeah, we are going to do rhombus. That is true. So we will do rhombus. But there was another one, a kite. So what we're going to do is find the area of the kite. All right. So, and this is actually fairly easy. I'm going to draw one right here. You guys taking notes? Shouldn't be any reason to talk if you're taking notes. Should be drawing what I'm drawing. And then I'm going to take this. I'm just going to eyeball this about right there. Trying to make it look like this one, except it's tilted down the other way. And then take that to there. There you go. That's a pretty good looking kite. Yeah, I can do this as well because I'm going to need this. Yeah, that's pretty good. All right. Again, in the honors class, we went through and showed them like where this formula came from. I don't think you guys really care. I don't think they really care, to tell you the truth. But that's all right. Tell you what, let's color code these things. All right, let's make this one yellow. And let's make this one right here blue. University of Delaware colors, right? If I can make it blue. Let's try this again. There we go. All right, there's University of Delaware. All right, so do you see these two lines right here? What do we call those lines right here? When I go from a vertex to another vertex in a quadrilateral or any polygon, it starts with a D, a diagonal, okay? So they're diagonals. So we'll call this one D1. Now the D1 is not just, it's not just from Q to the middle. It's from Q to S. Everybody see that? So the D1, I put it in yellow, so the whole yellow thing is D1. So what do you think I'm going to call the blue one? D2. You okay with that? All right, so the yellow one is D1, the blue one is D2. Watch how easy this formula is. Again, this is another one that you want to add to your list. You should have an ongoing list, a running list of all your formulas. So here is the area of a kite. I'll just put K for a kite. Watch how easy it is. It starts off just like the triangle and the trapezoid. How did the triangle and trapezoid start off? 1/2. But now watch what you do. Again, if you really want to know where we came up with this formula, you could always watch the video with the honors class, but I don't think you really care. So let's just tell you what it is. It's D1 times D2, and that's it. You just multiply the two diagonals and then take half of it. That's all you have to do. It's not hard, is it? No, you just have to remember it. That's the hardest part, is just remembering it. Okay, but doing it is actually pretty easy. All right, so you find the one diagonal, this one going here. You find this one right here. You multiply them together, and then you take half of it, or you divide by 2. Yes. Man, everybody's bailing on me today. Let's do an example, and then we'll be finished, okay? So, at least for the first part of this section. I'll tell you what, I'm not going to redraw a picture. Let's just put some numbers in here. Is that all right with you? I'm sure you don't care. Do you remember what, on a kite, do you remember what happens to this yellow line? What if I told you from, we'll call this X. What if I said from Q to X was, oh, there's a little trick to this. 115, but watch what they put it in. They put it in millimeters. Okay? I shouldn't have made that blue. I should have made it yellow. So from Q to X is 115 millimeters. Okay? What is it going to be from S to X? Remember what happens to that yellow line? It's what? Just take a wild guess. How is it split? Where is X? On this yellow line right here. Just take a wild guess. What does it look like? It's in the middle. That's right. So if this is 115 right here, then what's this one going to be right here? From S to X. It's going to be 115 because it's being bisected. All right, go back and watch the video on kite. We've talked about that before. So if this is one, because they only give you one of these. They just tell you that that's 115. And they also tell you that this is, oh, I should have put that in yellow. Do you mind if I try? Let's put that in yellow. There we go. That's better. Now I feel better. All right. Now, here's the deal. They tell you that this part right here is 30 centimeters. Now, look, this is important. This is 115 millimeters, and this one is 30 centimeters. And they tell you one more. They tell you this little bit right there is 13 centimeters. So, what do? Well, first of all, what is the whole entire QS? Because we want to find the diagonals, right? Is anybody still with me? I got like 3 people looking at me. So look, I got to find one of these diagonals. So what's this whole diagonal QS? If this is 115, what's this little bit right here? That's 115. And that's, whoops, almost put centimeters. That's in millimeters. What's the whole QS going to be? 230. That's right. How'd you get 230? Just adding them up. Exactly right. Because if this is 115, that means this is 115. To find the whole entire yellow diagonal, you just add them up, and that gives you 230. But it's 230 what? Millimeters, right? Okay, let's go to the blue. What's the whole diagonal PR right here? What's the whole PR? What is it? 43, very good. So, but it's not just 43, it's 43 what? You didn't give me a pass?
No, but you could text me.
It's 43 what? It's not millimeters, it's what? Centimeters. Now, can I add up 230 millimeters plus 43 centimeters? No. I'm going to have to change one of them to the other. You with me on that? Like if I had 5 inches and 3 feet, that's not 8 anything, is it? Okay, I'm going to have to change one to the other. Same thing here. So which one do you want to change? I think one is the easiest thing to change. Anybody have any ideas? How do you change from millimeter to centimeter? Jasmine, you should be able to do this. You grew up on the metric system, right? So us Americans, we're so stuck on the old system. Nobody learns metric anymore. But metric is so much better. It's so much easier. We should all go to the metric system, to tell you the truth. But Americans are too stubborn. The rest of the world's doing it except for us. I don't know why. But watch very carefully. I only got a minute left. So if I'm going to go from millimeters to centimeters, how many centimeters is 230 millimeters? It's just a power of what? 10. It's just a power of 10. So do I either move the decimal to the right or to the left? Which one is going to be? It's going to be to the left. So it's going to be 23 centimeters. Wait a minute. Am I finished? So that's one diagonal. Shh, guys, I'm still talking. We're not finished. The bell doesn't mean anything to me. Let's watch. How do I find the area now? I take 1/2 and then I multiply the diagonals. What do I have? 23 times 43. Put that in the calculator and you get 494.5. This is centimeters, so it's centimeters what? Squared. Okay. We will continue this tomorrow.